Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst is an end-to-end data lakehouse platform built on Trino, the query engine Apache Iceberg was designed for. Starburst has complete support for all table formats, including Apache Iceberg, Hive, and Delta Lake. And Starburst is trusted by teams of all sizes, including Comcast and DoorDash. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst today and get $500 in credits to try Starburst Galaxy, the easiest and fastest way to get started using Trino. Your host is Tobias Macey, and today I'm welcoming back Lior Gavish to talk about the impact of AI on data engineers. So, Lior, can you start by introducing yourself?
Hi, Tobias. Thanks for having me today. I'm Lior. I'm the co-founder of a company called Monte Carlo. We're the data observability company, which means we help data teams, data engineers, data analysts, data scientists create reliable and trusted data for whatever they're using, whether it's analytics or machine learning or increasingly AI. We've been around for about 5 years. We're now serving over 400 data teams and growing quickly. And we love everything data, so it's always exciting to be on the show.
As I mentioned, you've been on a couple of times before, but for anybody who hasn't heard your past appearances, which I'll link in the show notes, can you just refresh our memory as to how you got started in data?
Oh, absolutely. I got started in data, I want to say over 15 years ago, as what you would typically call today a machine learning engineer. I was actually building NLP models to help summarize and classify news articles. That's how I started. I then went on to start my own company in cybersecurity and used analytics and machine learning to solve certain kinds of fraud use cases. Company got acquired by a bigger, larger than public cybersecurity firm, and I went on to lead the data and engineering teams. There are about 100 people, building various kinds of real-time protection from fraud and cyber attacks, and heavily relied on analytics and machine learning. So kind of my background is a combination of engineering and data, and therefore also my interest in how do you operationalize data and how do you make it actually as reliable and as trusted as it could be when it serves real-time applications and sometimes millions of users. So that's my background and the gist.
It's always interesting in this world that we're in now of large language models and generative AI, hearing the terms natural language processing and the fact that you were working so hard to be able to summarize those news articles when now people just say, oh, I'll just throw it at ChatGPT and it does it for me. But there are also, of course, the issues around quality and accuracy in those summarizations. So.
Yeah, the scratches on my back. What I spent months on end trying to build with very custom and specialized algorithms you can now do with an API call that costs fractions of a cent. So there you go. There's some progress in the world.
And nowadays, whenever somebody says the word AI, the assumption is that we're talking about ChatGPT and the like. But for purposes of this conversation, when we're talking about the impact that the current phase of AI is having on data teams and data engineers in particular, I'm wondering if you can give some clarifying detail about what you mean when we're saying AI for the purposes of this conversation.
It's a great point. I think AI, the debate of AI and ML and what's AI has been going on for as long as I can remember, and it's always been there's been a lot of opinions on it. I think for the sake of this discussion, we could probably think of AI as generally speaking the generative AI models that emerged in the last almost 2 years now. So think, Chat GPT, OpenAI, and now more recently, various kinds of llamas and Mistral and Anthropic and whatever. I think those models introduce kind of a foundational shift in how we think about using AI, and I'm not sure we're super close, but it's probably the most promising avenue to true machine intelligence, potentially getting closer and closer to human level intelligence. And so for for right now, I'm thinking about AI mostly as those large language models that have been introduced pretty recently.
Machine learning went through a bit of a resurgence 5 years ago, thereabouts, with the idea of ML engineers and the work of actually bringing machine learning into the real-time application experience for end users and ML ops. So there's been a lot of that conversation happening for a little while now. With the advent of generative AI and the new demands that they're placing, particularly thinking in terms of things like prompt engineering, retrieval augmented generation, the fact of the models themselves being so much bigger, I'm curious if you can start by giving a bit of an overview of what you're seeing as the new requirements and the new features that are required in data platforms for being able to support these new categories of model in an operational environment.
Absolutely, you're right. About 5 or 10 years ago, there's been an explosion of tools to bring machine learning into production, whether it's feature stores and model serving frameworks and model versioning and all kinds of different technologies. Generative AI has brought in a new stack, and I'm happy to go through the different components of that stack. I think first and foremost, and the thing that probably many of our listeners have used are the model APIs, right? And OpenAI did something very cool, which didn't exactly exist in the ML world. It basically made models a commodity by serving them as an API, right? You can make a very simple HTTP request to OpenAI and now to many other providers and get access to the latest and greatest model that's been trained by 500 PhDs and $1 billion worth of GPUs, right? And that's a really core part of the stack that everybody's familiar with. Having said that, over the last 2 years, there's been a lot of other components that kind of emerged to help teams build with generative AI. First and foremost, RAG. You mentioned it. It's this idea of, well, how do we add long-term memory and other capabilities to these large language models? Retrieval augmented generation is the probably the most dominant way to do so. And it's this idea of, let's take a lot of data, typically unstructured data, but sometimes structured data, put it in a database and make it available to the model while it is responding to user prompts, right? So, for example, a very simple example, if I want to use a model to answer a lot of questions about my documentation, my developer documentation, I can put all of these documents that have existed, that have been built over the years, into a database. Specifically, I might use a vector database. And then when the model gets a new question from a user about how to do this or that, it might use the database to retrieve relevant documents to the user's prompt, and then create an answer to that question using those documents. Typically by some form of summarization or extraction. And so RAG is kind of has prompted, if you will, a bunch of different technologies, most prominently the vector databases that probably many have heard of, but also, frameworks and libraries that help build those RAG applications. Next in line is probably various tools for fine tuning. It's fine tuning is this idea of, let's take a large language model that's been trained over maybe the entire internet and all of the books ever written and whatever it is, and then maybe let's customize it to to a more specific need. Maybe I want to have specific knowledge about some topic that's very relevant to my business problem, you can basically use a set of documents as a way to fine tune the model and add a certain specialization to it. There's a bunch of tools that will help you do that effectively. Most prominently, APIs coming from the model providers that allow you to add a data set, train a model, and then serve that model. But then also, again, other software tools to make that easier. The fourth technology that's emerging in terms of generative AI applications are what I broadly call orchestration technologies. So think frameworks like LangChain, but there's increasingly more and more frameworks, agent frameworks, prompt management tools, all kinds of different tools that help you basically create an application using generative AI. It allows you to make a series of or to orchestrate a series of calls to models, using the outputs of a call to trigger another call, using RAG in the midst, and combining models and prompts and information from a database in kind of interesting ways to create higher level abstractions, if you will, of these models. So that's been pretty exciting too. And then those four probably allow, from what I've seen, allow users to create pretty sophisticated applications using generative AI. And then as you take these things to production and expose them to a broader set of users, potentially external users outside of your own company, there's a couple more sets of tools that come up. First and foremost, security. Generative AI opens a lot of possibilities in terms of things that could go wrong in terms of security and privacy. And so we're seeing more and more tools that help you manage that in real time. Generally speaking, AI firewalls. That's kind of interesting. And then, of course, the topic that's near and dear to my heart, the reliability and quality tooling, whether it's observability of the type that we work on in Monte Carlo, which the idea of monitoring the quality of the Gen AI system in production, but also obviously pre-production tools that help with evaluating new versions of an application or new versions of a model, et cetera, et cetera. And so all these kind of different tools are coming up. Lots of companies that are trying to build those. Lots of teams are trying to build those in-house. Very exciting. I would generally categorize, I think it's just helpful to remember how you might get those tools. I think there's kind of three big options here. You can either buy those tools from cloud providers like AWS, GCP, Azure, and increasingly OpenAI, and that's what most teams do, as far as I can tell. Then increasingly, there's good end-to-end offerings from the data clouds, from Snowflake and Databricks. Both offer a pretty robust set of tools across all of these categories to help data teams build with AI. And then of course, find specialized solutions for different parts of the stack. So whether it's Pinecone for vector databases on the RAG side, or Monte Carlo on the observability side. But of course, when you need to upgrade from the basic version to advanced use cases, you can definitely find highly specialized and professional tools for each part of the stack now. So yeah, it's there's a lot that's coming into the stack to enable generative AI, and lots of new technologies, lots of new tools. Having said that, I do still think the foundation is the classic data pipelines, right? The one thing that I think people are realizing is that no matter how you go about generative AI, the core piece is marrying those models with the data that you manage anyways, right? If you don't combine your own data with the models, you're basically building a commodity, right? Something that ChatGPT could do. The whole point is how do you create a unique, specialized, personalized experience for your own users that heavily relies on your own data, and then what everybody ends up doing is building lots of data pipelines to feed those models with their own proprietary data and make those models useful in the context of their own business and their own users.
There are a lot of different pieces that you talked through there. Some of them are new infrastructure components. Some of them are just new practices and how to actually manage the model and the end user application. I'm curious what you have seen as the ways that teams are thinking about which of those components are the responsibility of the data engineers, which are the responsibility of ML engineers, if you have them, which of them belong to the operations and infrastructure teams, which of them belong to application engineers, and just some of the ways that you see the breakdown of who owns which piece.
Such a good question. It's a melee right now. It's so hard. There isn't. I wouldn't say there's an established path to building generative AI, and every company does it slightly differently based on the specific org structure and talents that exist in that team. To be clear, there's you need all, right? There's an element of software engineering here because you are building an application, typically a web service, typically with some form of user-facing application. There's a good element of data engineering here with data pipelines, as we discussed. There's some element of machine learning engineering, or ML engineering, and data science here when it comes to exploring the models and understanding how to use the data, and also, to be honest, generative AI, at least right now, is most effective when it's combined with more traditional ML and sometimes deterministic approaches. The combination is actually very powerful, and data scientists are actually good at making this whole thing work nicely together. And of course, there's product managers and product designers involved because again, it's an application. It needs to work in a way that makes sense for its consumers. And so what I typically see is all of those teams involved in various capacities, and everybody focusing on their own pieces. I think and all those teams also employ those different pieces of the stack in different ways. Just to give you an example, a software engineer might use a model API, right? Something like OpenAI, to generate a response, sometimes maybe in real time to a user prompt. And a data engineer might use that same API to process text documents in bulk as part of a pipeline, right? And a data scientist might use it in a third way. And so right now it's a mix. I don't think there's clear ownership of who does what, and we're definitely seeing software engineers building data pipelines and data engineers building user-facing applications. I think over time, we'll probably get to some, some best practice or some understanding of how to, how to split all these different components between the different teams. And what I suspect is, we'll definitely see much more or multidisciplinary team tackling this, right? And and this existed for a while now. Teams that are made up of software engineers, data scientists working together, but it was probably the exception, not the rule. I think with generative AI, it's increasingly going to be the rule, if you will, and we'll see those teams kind of working together to build solutions and full applications.
Another interesting aspect of the ways that generative AI is turning everything on its head is that for a long time it was the case that data engineering was there to support data science, and then it turned into machine learning. And now we're seeing it come full circle where these generative AI technologies are also being used in the data engineering workflow of pipeline design, transformation generation, code generation. And I'm wondering how you're seeing data engineers start to bring generative AI into that development flow and into the work of building and maintaining the data pipelines that then go on to feed the generative AI.
Yeah, absolutely. I think it's kind of what you mentioned, Tobias, right? Like it starts from what a lot of engineers are doing right now, which is use various kinds of co-pilots to accelerate development. And in the case of data engineers, you can very effectively use generative AI to build your pipelines, whether you're using PySpark or SQL or what have you. Generative AI can probably accelerate some elements of it. We're not quite there in terms of replacing data engineers with AI. We would never get there, but it can certainly make people more productive. I think it can even, or the other thing that's happening a little bit. I think it generative AI democratizes access to these things, right? So the whole text to SQL thing is working pretty decently, which means that maybe certain things that used to be delegated to data engineers when there's a need to create a new pipeline or a new analysis. Now maybe someone with less technical skills can do it using generative AI models. So it's kind of democratizing access to data and to pipelines, and that actually frees up data engineers to do the things that they do best rather than answering to ad hoc requests. I think the most exciting thing though for data engineers is actually that generative AI unlocks access to unstructured data. And what I mean by that is imagine a lot, and there's plenty of examples, but a lot of enterprises have a lot of very useful unstructured data documents, basically generated in the business. Whether it's legal documents or technical documentation or lots of other corpus of information that are useful. If you wanted to make these things useful for the business in the past, a data engineer couldn't do it. They would need a data scientist and a machine learning engineer to come in and process that data and generally extract structured data from it, right? If you wanted to process all your legal documents and extract information from there, you actually needed to hire highly specialized data people that would build NLP algorithms, quite like I used to do 15 years ago. In order to do that, and the data engineer would help them kind of string things together and build the pipeline, but still a lot of the work would have to be outsourced in a way. And now data engineers can actually do that on their own, right? Especially with models being available natively in tools like Snowflake or Databricks. A data engineer can take a body of legal documents and extract information from there without getting any help. It's as easy as creating a prompt and applying a function to that data set, right? And so I think that's a force multiplier, right? It opens up opportunities for data engineers to use enterprise data much more effectively and with much less help from other teams that they might have depended on in the past. So that's a pretty exciting shift and change in my view.
One of the other major ways that AI and machine learning models have found their way into the data engineering workflow is in particular in that context of retrieval augmented generation, where you need to be able to generate the vector embeddings of the data that you want to use for that context. And so you have to have some capacity being able to run those embedding models in that pipeline workflow and pipeline environment. And you also need to be thinking about what are the considerations around how I want to generate the embeddings. What do I need to be thinking about as far as chunking of the different sizes of embeddings that we're creating? And I'm wondering if you can talk to how those new requirements are being addressed in data teams, and some of the new skills and new training that's necessary to be able to build pipelines to support that RAG use case effectively.
Yeah, absolutely. I think the so as I said, incredibly helpful for data teams, right? There's a lot of value in being able to process unstructured data, and to be honest, I would dare say that at this point there isn't yet a best practice. Like you can't buy a book and understand how to build RAG. Although I'm sure someone is selling a book, nobody really has done that a ton. You can hire a RAG expert that will tell you how to do it. It's mostly about getting hands-on experience and being curious and experimenting and finding what's right for your particular use case and your particular need. And so I probably couldn't give people advice on how to build RAG pipelines at this point. And I've seen so many different approaches, oftentimes highly dependent on the background of the people building the pipelines, right? Software engineers attack it in a certain way, and then data engineers do it in a completely different way. And both are very valid right now. I think that the having said that, there's probably a few things that people need to start thinking about in terms of how to build that effectively, right? And essentially, like how to go from that prototype phase of take a bunch of documents, run them through a LangChain, and create and put them in a vector database. That's something that we're all learning how to do. To take it to the next level, there's kind of a higher level questions that need to be that we're seeing teams increasingly ask. It's things around security and privacy, for example. Like, how do you make sure that whatever access controls apply to that data, and whatever sensitive information is there continues to be governed as it goes through data pipelines. Over the years, we've developed various methodologies around that in the structured data world, but applying it with unstructured data is quite different, because it's messy, because you take a body of documents, and honestly you don't even know what's there and how it should be protected. So there's much more potential for leak and for people having access to things they're not supposed to see. So that's definitely an area where people need to develop a knowledge and a set of best practices around, again, that apply to their business. The other one is cost and efficiency. Again, building a prototype will probably not cost you a lot of money and nobody would care. But now, if you process the entire corpus of enterprise data and run in a batch every single day in your pipelines, and make, I don't know how many API calls per document, the bill can run pretty high pretty quickly. And so data teams need to figure out how to create visibility and manage that cost, but also how to optimize it, because a lot of use cases end up being exorbitantly expensive. And so you need to think about how to minimize the number of calls, and then how to potentially use faster, cheaper models where it applies. Cost is a thing, and of course, reliability and quality, right? These pipelines tend to have a lot of issues with that, right? It's first and foremost hallucinations, right? Everybody that used ChatGPT has probably gone to a restaurant that never existed. They asked for a recommendation for dinner, and a true story. And so you need to figure out how to deal with those things, how to deal with the fact that it's not deterministic, right? Like how do you even understand the quality of the output? And even if you painstakingly go and look at a lot of results and evaluate them in various ways, and there are lots of techniques around that. How do you make sure that that remains true as you release changes to the pipeline or changes to the underlying model that you're using, and things like that? And so that's something that I think there's a lot of skills to be learned around. So yeah, lots of things to learn. I have more questions than answers around this, but yeah, it's exciting times, and I'm sure that over the next couple of years we'll gradually learn how to do all these things effectively.
Yeah, it's funny how much that is the case right now. Of I have a lot of questions and I have a lot of ideas, but there aren't any established answers yet because all of it is too new, and so everybody's flailing around in the dark and making their best attempt, and eventually we'll convene on a set of best practices, but we're not there yet.
Yeah, too early to call, I'd say.
One of the other interesting side effects of the current stage of AI and the rise of generative AI in particular is the growth and interest of vector databases, vector indexing. So we're seeing a new growth of that particular segment where it seems like every day I hear of a new vector database that's out there and optimized for some particular use case. Vector databases as a technology predate the current AI craze of generative models for, in particular, things like semantic and similarity searching. And I'm wondering if there are any other aspects of the ways that AI applications and generative models in particular are bringing some of these new technologies or newly created categories into the data engineering ecosystem, and how those are being used outside of that context of just supporting generative AI models.
Vector databases generally use, or in addition to being used in kind of RAG scenarios, I think people are really excited about the traditional search. I've talked to this company that works, that's an ad tech, one of our customers, and there's certain workflows there where you help marketers find relevant places to place ads. And traditionally that's been done with basically Elasticsearch, right? Some form of keyword search with a lot of bells and whistles around it. But and they've gradually introduced vector embeddings and then vector database of that process, right? And not in the context of RAG necessarily, but just if you want to find a place to put your ad about, I don't know, a fitness subscription or what have you, finding places online that match that with, and vector databases actually do that extremely well, apparently much better than traditional search. And so there's a resurgence of search now with vector databases available, and of course those powerful language models that create the embeddings. It seems to create better, higher relevance results with kind of a deeper semantic understanding. That's of course been available on Google or in other search engines that have been highly optimized over the years, but now probably smaller use cases can be built quite rapidly and have very, very powerful semantic search using vector databases and embeddings.
Now, bringing it back around to the question of reliability, quality, we have been fighting that battle for a few years now in just the pure business intelligence, data analyst type use case of how do we build more reliable systems. Now, with the added stresses and requirements around AI applications and these very probabilistic and not deterministic use cases. How are you seeing that impact the way teams are thinking about reliability, data quality, data observability, and some of the ways that you're thinking about that at Monte Carlo to be able to help support those teams?
Yeah, great question. First of all, like everything, we're still learning. There's more questions than answers, but I will call out kind of based on what we're seeing. First of all, it all goes back to basics in a sense, right? Pipelines are pipelines, and you have to make sure they're working reliably, right? You have to make sure that vectors or tables, you have to make sure they're getting updated on time. You want to make sure that you have all the data set there, that nothing is missing. You also want to make sure there's no duplications, and duplications are particularly bad in vector databases because they really hamper your ability to get the k nearest neighbors and get the most relevant documents there, because you might get 5 copies of the same document if you have it in the database. And so you want to make sure these things are working. And of course all the structural stuff, right? Do you have the right vector dimension that you're expecting, and did you use the right embedding model and a consistent embedding model, right? It's very important to use the same embedding model in the pipeline and during retrieval, right? And of course the metadata around it, right? Vectors are always accompanied by metadata that helps trace them back to where they came from, or associate them with an account or a user or other things. And you need to make sure that the metadata is there and it's complete and it's accurate in the same way that structured data was tested. So all these things are there. And of course, lineage too, right? In order to effectively manage the quality and reliability, you need to understand where those vectors came from, how they're consumed downstream, all that good stuff in observability, right? When you have a problem, you need to understand what its impact downstream is, and to find the root cause, you need to understand what's upstream. So all these things are kind of classic things that translate from structured data to unstructured data pretty directly. The one thing that's a little bit different is, well, how you measure the quality of the data itself. And in the structured world, we developed a lot of methodologies, right? Like we can calculate a lot of quality metrics, like how many nulls you have and how many duplications and all sorts of these things. And we can have people that understand the pipeline build more precise metrics around it that maybe take into account a deeper understanding of the data set and the business. And that doesn't translate as well to text or image data that goes into vector databases. But we're seeing increasingly methods to deal with that. So as an example, we're seeing people doing things like, well, I could probably use generative AI to calculate quality metrics about unstructured data. As an example, I could take all the text that I have and I could use a model to, for example, classify it into topics, right? And track what topics I have in the data set and make sure that's stable and that's behaving as expected over time as the data set changes and shifts or goes through the pipeline. So that's an example. I could also use generative models to determine whether there's sensitive data or PII inside the set, right? And track it over time, and so on and so forth. You can get really creative with how you use generative AI to create quality metrics on top of unstructured data. And I think it's a very promising avenue. But of course, a lot to be learned there. It's complicated and it's early days. And if I'm honest, if you talk to data teams building generative AI pipelines today, a lot of it still relies on people eyeballing results and trying to make sure that they make sense. It's not always easy to scale and automate these things. And so we're gradually learning how to take bites off of that manual process and turn it into a more consistent and automated approach.
As you have been navigating the rapidly changing landscape of data in the face of generative AI and the ways that data teams are working to adapt and ways that you at Monte Carlo are trying to help support them, I'm curious, what are some of the most interesting or innovative or unexpected ways that you're seeing AI impact those data engineering teams?
Yeah, so many exciting examples here. I'll name a few. I think one really exciting trend is, I think the fact that we're unlocking structured data is bringing data engineering closer to the forefront of decision making. And the example I like to quote here is, I was talking to this sports team, professional sports team. It's one of our customers. And, in the past, data engineers could provide some structured data out there about players, right? Certain statistics about how they performed in matches, but that data is pretty sparse, right? And it's only available in the top leagues. But if you're trying to spot the next, the next generation of talent, the people coming from lower leagues or from high schools, and you're trying to scout, the next star, it's really, really hard to get structured data about that, and it can be extremely unreliable. But there is a lot of unstructured data. Lots of scouts out there writing reports about players, all around the world. And so data engineers were actually able to use AI to parse out that unstructured data and, in fact, structure it, right? Measure sentiment there, and then use methodologies with structured data to extract intelligence out of it, right? You can benchmark the same player over time. You can benchmark the scouter. You can really get a lot of good insight, and that really brought the data engineers to the forefront of the of the sporting professionals, and made them superstars, essentially, right? And automated something that was extremely hard to do prior. Another example where generative AI actually allowed data teams to get in front of the customers of that organization, and I'm thinking here about a cybersecurity company. And in cybersecurity, there is a lot of unstructured data, things like security policies and various documents in the enterprise, and lots of exchanges of documentation between companies trying to deal with each other and buy technology from each other. And that data team was able to do a bunch of different cool things with generative AI, whether it's responding to questions based on a body of documents that describe all the security policies, or whether it's in compliance, translating policies to controls automatically, things that are really, really high value for that company's customers, that have been built almost exclusively by data engineers. So it kind of really brought them to the forefront. No longer a platform team working for analysts, but rather serving the company's customers directly. So that was pretty exciting. And then even saw this one data engineering team that was able to actually generate new revenue for the company in a pretty direct manner. It's an energy company. They get requests for quotes all the time, people asking them to provide a certain supply of energy at a certain time and location, and they were able to, and historically they haven't been able to serve all those requests for quotes. They get a lot of these, and that's potential revenue, right? If they're able to respond to a quote, that might turn into a customer, right? And so they basically turned this from this very manual process where humans take in request by request and try to respond to it. They automated it, and using generative AI, and data engineers were able to suddenly generate a whole lot of new revenue, just from automating that process and solving the manual labor attached to it. So I think the point is, data engineering is becoming even more valuable and impactful in the business, more than it's ever been. So, and that's exciting news.
And in your own work of building a product that is supporting people in this space, trying to understand the impact that AI is having on data and the ways that teams are building these systems, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
I think probably the biggest challenge, a couple of big challenges. One is understanding where and how generative AI can be applied, to serve our customers. We brainstormed, I want to say, over 70 use cases in data observability that the generative AI can support, and it's pretty challenging to understand. Well, where does it work well? Where can it be applied to the maximum effect? Where can it make the most impact? And where can it work as reliably as we need it? Which leads to the other challenge. It's extremely, or it's not incredibly hard to get to like really cool demos with generative AI, right? You can find almost any use case you can think of. You can find a few examples where generative AI really blows your mind in terms of what it can do, which I think is why the world is so excited about it. It's a whole other ball game to bring it to production, right? It's a whole other ball game to do it in an environment where you can't expect it. You can't predict all the inputs, or maybe you can't predict them, but models are undeterministic, so they work only part of the time, and there's a lot of art and science that goes into figuring out how to make these generative models work well enough so that they can serve a human trying to accomplish a task in their day-to-day life. And I think the biggest learning there was really that combination between generative AI and more deterministic approaches. For example, using generative AI to get an answer, but then validating it against heuristics or statistical models in order to make sure that response makes sense and is valid for a human to use. And so those are probably the biggest challenges I've experienced personally while building with generative AI.
For people who are trying to navigate this current stage of the data ecosystem, what are some of the cases where you're seeing AI as just being the wrong choice and not something that is worthwhile to invest in or try to incorporate into your data stack?
Oh, good question. It's not the wrong choice, but I see a lot of, or the common pitfall I see is the Microsoft approach of let's throw a co-pilot or a chat interface on every problem, right? And just assume that what people want is to interact with in natural language with whatever they were doing before. And that's sometimes valid, and it can be useful in certain scenarios, right? And you know, in certain cases, I'll use an example from data engineer. Text to SQL can be very effective, but you really have to think about the end user, right? They may not care, or natural language questions are not the answer to any problem, and sometimes people would just rather interact with interfaces the way they are, right? Sometimes that's easier and simpler and works more reliably. And so I'd probably say it's important to think about where generative AI really allows people to do something that they haven't been able to do before, and where generative AI has an unfair advantage, right? And we talked about some of these things, but extracting structured information from unstructured data is really exciting and something that people couldn't do before. But interacting in natural language with a dashboard, maybe not as groundbreaking as you might think, right? Sometimes it is, but oftentimes it's not. And so I would just think about that kind of idea of where can generative AI really stand out and have a competitive advantage, quote unquote. And the answers are not always obvious.
What are some of the trends that you're keeping an eye on, or some of the predictions that you have on the ways that AI is going to impact data engineering in the medium to long term?
Good question. I think we'll continue to see some of the things that we've already talked about. It'll get easier to build pipelines. It'll get easier to democratize data. It'll get easier to put data engineers to work on the hardest, most high value problems. So that's definitely happening and will continue to happen. We'll continue to see more unstructured data being processed and being fully put to use by data engineers. I think it's probably the most exciting element of generative AI. And then also, as a result of these two things, I think it'll bring data engineers closer to the customer, closer to the revenue, closer to decision making in a way that data engineering teams have never been before. So we'll continue to see that in the long term.
Are there any other aspects of this topic of AI and the impact that it's having on data engineers and data engineering teams that we didn't discuss yet that you'd like to cover before we close out the show?
I'll probably again kind of going back to the basics, right? Generative AI is cool and shiny, but in order to make it work in the real world, we have to do all the things that we know we have to do, right? We need to build solid pipelines. We need to make sure they're cost effective, that they're properly governed from a security and compliance perspective, and of course make sure they're reliable and high quality, because at the end of the day, those models, as smart as they are, can't overcome a security breach. They can't overcome garbage data, and they won't be successful if they're cost prohibitive, right? And so we need to make sure all these fundamentals work well. And at Monte Carlo, we're excited to tackle the reliability and quality aspects of it. And we're also excited to see how other vendors and stacks will help with the two other challenges. So yeah, back to the basics.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Oh, good one. Data management. I think it's not necessarily one tool, but with the themes that we've spoken about today in mind, I think we're seeing a consolidation of the data engineering stack and the software engineering stack. And I'm kind of curious to see how we're going to marry, or like to see more easier ways to marry together those data pipelines and those customer facing applications, in the same platform, working nicely together. I think there's some interesting opportunities in stitching those two worlds and making the whole system work nicely together for a team where there's a software engineer, a data engineer, and the machine learning engineer all working together to build a single platform, a single application.
All right. Well, thank you very much for taking the time today to join me and share the ways that you're seeing AI be an impact on and for the data engineering teams out there. Appreciate all of the time and energy that you and your team are putting into helping to support those folks. So thank you again for taking the time today, and I hope you enjoy the rest of your day.
Thank you, Tobias. Super fun.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.